Everything you know about space is a lie. The Big Bang never exploded. The sun is not yellow. A black hole on the far side of the moon does not exist, and the far side itself is not dark at all, while meteorites falling to Earth as glowing fireballs are actually cold. Sounds absurd? Now I will prove each of these statements. Imagine you have believed one thing your whole life. You drew a yellow sun as a child, watched movies where spaceships maneuver between asteroids, listened to a legendary album about the dark side of the moon. And then it turns out that reality is completely different. It does not just differ slightly, it completely overturns your understanding of the universe. These are not conspiracy theories or fictions. These are scientific facts that are somehow persistently ignored by popular culture. Question: why does this happen? Why do we continue to believe in what has long been disproven? Maybe because the truth is too complex, or because myths are more beautiful than reality? Or maybe it is all because once information is learned, it eats into the consciousness so deeply that it is impossible to erase. Children's drawings of a yellow sun, school textbooks with simplified diagrams, Hollywood blockbusters where physics is just an obstacle to spectacle. Today, we will break down 6 of the largest, most persistent space myths. Not about the Great Wall of China visible from space. That is too simple. We will dig deeper, to where the very essence of things is distorted, where lies have grown so much into the collective consciousness that they have begun to be perceived as truth. Get ready. After this video, your understanding of the universe will change forever. Before we start destroying illusions one by one, support the channel with a subscription and a like. This will help the algorithms show our content to more people who also want to know the truth about space. And now, into the battle against misconceptions. Let us start with the biggest myth, literally of cosmic proportions. The myth of how our universe began. You have probably heard of the Big Bang. 13,800,000,000 years ago, a colossal explosion occurred at a certain point in space. A blinding flash, an expanding sphere of fire. Matter flies in all directions like fragments of a grenade. From this chaos, stars, galaxies, and planets gradually form. Beautiful, understandable, spectacular, and completely incorrect. The problem began with the name itself. The term Big Bang was coined by English astronomer Fred Hoyle in 1949. And you know what? He came up with it mockingly. Hoyle did not believe in this theory. He considered it absurd. He wanted to ridicule the idea that the universe once had a beginning. For him, it sounded too religious, too much like the creation of the world. Hoyle was a supporter of the steady-state theory, claiming that it had always existed and would exist forever without beginning or end. But the irony of fate is that his sarcastic name stuck. Moreover, it cemented a completely false image in the public consciousness, because when people hear the word explosion, they imagine a bomb, dynamite, a fireball expanding in empty space, some center where everything started, and the surrounding void where everything flies apart. However, the Big Bang works completely differently. Imagine a balloon. Draw several dots on it with a marker. These will be galaxies. Now start inflating the balloon. What happens? The dots move away from each other. But pay attention. Not one of the dots is the center of expansion. All dots are equal. And it is not something inside the balloon that expands. The surface of the balloon itself expands. Space itself stretches. This is exactly how the Big Bang works. It is not an explosion in space. It is an explosion of space itself. It is not matter flying away from some epicenter that expands. The very fabric of reality expands, and galaxies are simply glued to it like dots on a balloon. There is no center, no edge, no void around it into which something flies apart. The Big Bang happened everywhere simultaneously. Right here where you are sitting now, 13 billion years ago, there was also a Big Bang. And where the neighboring galaxy is located, and where the edge of the observable universe is, everywhere, at every point in space. This is hard to imagine because we are used to ordinary explosions. You throw a firecracker, it explodes in a specific place, fragments fly in different directions. But space works differently. It is not an object inside something larger. It is that larger thing itself. Now let us dig even deeper. What was there before the Big Bang? The question seems logical, but it is incorrect because the very concept of before assumes the existence of time, and time is just as much a part of space-time as the three spatial dimensions. Time began together with the Big Bang. Asking what was there before is like asking what is north of the North Pole. The question has no meaning. Albert Einstein showed that space and time are a single four-dimensional fabric called space-time. This fabric can bend under the influence of mass and energy. Black holes curve it so strongly that even light cannot escape. And the Big Bang is the moment when all this fabric began to expand from a state of unimaginable density. What was this density like? Imagine that the entire mass of the observable universe, all the trillions of galaxies, each containing hundreds of billions of stars, was compressed into a volume smaller than an atom, smaller than a proton, smaller than a quark. Physicists call this state a singularity, a point where our mathematical models break down, where the laws of physics stop working. But even here it is important to understand. This was not a point in space. It was all of space compressed to unthinkable sizes. And when it began to expand, and this happened incredibly quickly, the temperature was colossal. Not just hot, trillions of degrees. So hot that even atoms could not exist. There was only a boiling plasma of elementary particles. And here the question arises, if it was not an explosion, then why do we see evidence of exactly an explosion? Why are galaxies moving away from us in all directions? Why, the further the galaxy, the faster it moves away? The answer is again in the same example with the balloon. When you inflate the balloon, all points on its surface move away from each other. Moreover, the further the points are from each other, the faster the distance between them grows. Not because they move faster, but simply because there is more stretching space between them. Galaxies behave exactly the same way. They do not fly through space, they stand still, and the space between them grows. This was discovered by American astronomer Edwin Hubble in 1929. He studied the light of distant galaxies and discovered a strange pattern. All of them emit light shifted into the red part of the spectrum. This phenomenon is called redshift, and it means that the light source is moving away from the observer. The further the galaxy, the stronger the redshift, meaning the faster it is moving away. Hubble realized the universe is expanding. If we rewind time back, we will see that once everything was compressed into one point. That was the beginning. Not an explosion in the usual sense, but the beginning of the expansion of space itself. But the evidence did not end there. In 1965, two engineers, Arno Penzias and Robert Wilson, were tinkering with a huge antenna, trying to get rid of annoying noise. They checked everything, cleaned the antenna, chased away the pigeons that nested there, but the noise did not disappear. And then they realized, this is not noise, this is cosmic microwave background radiation, the echo of the Big Bang filling the entire universe. When the universe was young and red-hot, it glowed, but as it expanded, the light cooled and lost energy. Today, this ancient light has reached us in the form of microwave radiation with a temperature of about -270 degrees Celsius. It is everywhere. Wherever you point the antenna, it is there. This is the afterglow of the birth of the universe. So why is the myth of the explosion so persistent? Because simplification is convenient. It is easier to imagine a bomb than the expansion of the very fabric of reality. It is easier to draw a fireball than to explain that space-time is not a stage where events unfold, but a participant in the events itself. And here is the paradox. The name Big Bang stuck exactly because it is wrong. It gives a false but understandable representation, while the correct explanation requires effort. It forces one to reconsider basic intuitive ideas about space and time, and few are ready to do that. But now you know, the Big Bang is not an explosion. It is the birth of space-time. It is the expansion of the universe itself, which continues right now while you are watching this video. Every second, the space between galaxies becomes a little larger, and someday in billions of years, the expansion may accelerate so much that even light from neighboring galaxies will not be able to reach us. We will remain in isolation, surrounded only by the stars of our own galaxy, while the rest of the universe will hide behind the event horizon. But that is another story. For now, remember the main thing. The Big Bang did not happen somewhere out there at a distant point. It happened right here. And the fact that we see an expanding universe is not the aftermath of an explosion, but the continuation of that very process that began almost 14 billion years ago. And now we move on to the second myth, the one you literally see every day but continue to believe in. Close your eyes and imagine the sun. What color is it? Yellow, right? Maybe orange at sunset? A bright yellow circle with radiating rays. That is exactly how we have drawn it since childhood. That is how it is shown in cartoons, books, and on national flags. A yellow sun is a basic fact that even a child knows. Only it is not true. The sun is white. Your brain is probably protesting now. How is it white? I see it as yellow. Right now, I will go outside, look at the sky, and it will be yellow. And this is where the most interesting part begins, because the problem is not with the sun. The problem is that between you and the sun, there are 300 kilometers of atmosphere. And this atmosphere works like a giant color filter distorting what you see. Let us look at how light works. The sun emits electromagnetic waves in the entire spectrum, from infrared to ultraviolet. Visible light is only a narrow strip in the middle, and in this strip, the sun emits all colors with approximately equal intensity: red, orange, yellow, green, light blue, dark blue, violet. When all these colors mix, our eye perceives them as white. Yes, exactly white, not yellow. If you were in space without an atmosphere between you and the sun, you would see a blinding white light. That is exactly how astronauts see it on the International Space Station. That is how probes located outside the atmosphere photograph it. No, we live on the surface of the Earth, and here the atmosphere enters the game. The atmosphere is not just a void with a small amount of oxygen. It is a dense mixture of gases filled with molecules of nitrogen, oxygen, water vapor, and dust particles. And when light from the sun passes through this mixture, a phenomenon called Rayleigh scattering occurs. Here is how it works. Light is a wave. Red light has a long wave, blue light has a short one. When a light wave collides with an air molecule, it can scatter and deviate to the side. And here is the key point. Short waves scatter much more strongly than long ones. Blue and violet light scatters 10 times more strongly than red. What does this mean? When sunlight enters the atmosphere, the blue and violet parts of the spectrum begin to scatter in all directions. They literally smear across the whole sky. This is exactly why the sky is blue. You look at the sky and see scattered blue light flying between air molecules before hitting your eyes. And what happens to the rest of the light? The one that goes directly from the sun to you. The blue part was subtracted from it. A mixture of red, orange, yellow, and green remained. And this mixture looks yellowish. The more atmosphere the light passes through, the stronger the effect. When the sun is at its zenith, directly overhead, the light passes through a minimum thickness of air. The sun looks almost white, slightly yellowish. But when the sun descends toward the horizon, the light goes tangentially to the Earth's surface, passing through kilometers and kilometers of air. Blue light scatters completely, then green scatters, then yellow, leaving only orange and red. That is why sunsets are red. Not because the sun changes color, but because the atmosphere filtered out all other colors, leaving only the long-wave red light that can break through the thick air. And here is the paradox. If the sky is blue because of scattered blue light, then why is it not violet? After all, violet light scatters even more strongly. The answer lies in the physiology of our eye. Our eyes contain 3 types of cones, receptors sensitive to red, green, and blue light. Violet light really scatters more strongly, but our eyes are less sensitive to it. In addition, the sun emits less violet light than blue. As a result, our brain interprets the mixture of blue and violet as blue. Now the most interesting part. Scientists call the sun a yellow dwarf. Hearing this name, people think, aha, so the sun really is yellow. But this is also a misconception. The term yellow dwarf is a classification by spectral class, denoted by the letter G. This classification was invented by astronomers for convenience, and it talks about the surface temperature of a star, not its real visible color. The surface temperature of the sun is about 5,500 degrees on the Kelvin scale. At such a temperature, a star emits light that in total gives a white color. Yes, the peak intensity of radiation falls on the green-yellow part of the spectrum, but this does not mean the sun looks green or yellow. It only means that in this region of the spectrum, slightly more photons are emitted than in others. But since radiation occurs across the entire spectrum, the resulting color is white. For comparison, hotter stars with temperatures above 10,000 degrees really look bluish because the peak of their radiation is shifted to the blue part of the spectrum. Cold stars with temperatures of about 3,000 degrees look reddish, while the sun is right in the middle and is therefore white. But the cultural myth turned out to be stronger than the scientific facts. We draw a yellow sun since childhood. There are yellow and golden suns on national flags. In symbolism, in heraldry, in art, everywhere the sun is yellow or golden. This is so rooted in the collective consciousness that even knowing the truth, people continue to automatically imagine the sun as yellow. And there is also a curious psychological point. When you look at the sun during the day, which, by the way, you should not do, you can damage your eyes. You see a blindingly bright object, so bright that the brain cannot clearly recognize its color. The brightness overloads the cones in the retina, and you see rather a white spot with colored halos. But when the sun is close to the horizon and loses brightness due to the thick atmosphere, you really see it as yellow or orange. And this image, the sunset sun, is fixed in memory as the real color. Interestingly, on other planets, the perception of the sun's color would be different. On Mars, where the atmosphere is much thinner and consists mainly of carbon dioxide, the sun would look almost white even from the surface. And on Venus, where a dense atmosphere is filled with sulfuric acid and carbon dioxide, the sun could appear as a dull yellowish spot breaking through eternal clouds. But that is no longer the color of the sun, but the color of the filter through which we look at it. And here is what is funny. Even scientists sometimes support this myth. In popular science books and school textbooks, the sun is often depicted as yellow simply because it is more familiar and more understandable to children. But by this, we reinforce the misconception in new generations. A child sees a yellow sun in a textbook, draws it in yellow, and now a false image is formed that will stay with them for life. The truth is that the sun is a white star, a hot, bright white ball of plasma emitting light in the entire spectrum. And only thanks to our atmosphere, this amazing filter, do we see it as yellow during the day and red at sunset. The atmosphere turns white light into a symphony of colors: blue sky, yellow sun, red sunsets. All these are optical illusions created by the play of light and air molecules. So next time you look at the sun, through special glasses, of course, remember, what you see is not its real color. This light is filtered by 300 kilometers of atmosphere, and the real sun is dazzlingly white, like snow on a bright winter day. And now we move on to the third myth, the one associated with the most romanticized aspect of space: weightlessness. You have probably seen footage from the International Space Station. Astronauts float through the compartments, somersault in the air, juggle water droplets, and play with food that hangs in front of them. Weightlessness, a magical state when gravity disappears and you can fly as if in a dream. Only gravity does not disappear anywhere. Moreover, at the altitude of the International Space Station 400 kilometers above the Earth's surface, gravity is almost the same as under your feet. 90% of the force that pins you to your chair right now. Your brain is protesting again, right? But the astronauts are flying. After all, they are in weightlessness. How is that? The answer is simple and simultaneously paradoxical. Astronauts fly exactly because gravity acts on them. They do not float in a void where there is no gravity. They are falling continuously every second. For more than 20 years that the ISS has been in orbit, it has been falling to Earth and can never fall. Let us look at what an orbit is. Imagine you are standing on top of a mountain and you throw a stone horizontally. The stone flies forward but simultaneously falls down under the action of gravity. The harder you throw, the further it will fly before falling to Earth. Now imagine that you threw the stone so hard that while it falls, the curved surface of the Earth moves out from under it. The stone flies forward, falls down, but the Earth moves away at the same speed. The stone continues to fall, but can never fall because the planet is round. It flies along a curve that follows the curvature of the Earth. This is an orbit, a constant fall in which you are constantly missing the planet. For the International Space Station, this speed is approximately 8 kilometers per second. Every second, the station flies 8 kilometers. This is the distance from the center of Moscow to some suburb. In the time it takes you to read this sentence, the ISS manages to fly several dozen kilometers, and all this time it is falling. Earth's gravity pulls it down, curving its trajectory, turning a straight flight into circular motion. The station falls, 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 but due to its huge horizontal speed, it misses the surface every time. Now, the most important part. The astronauts inside the station fall at the same speed as the station itself. The station falls, the astronauts fall. The station flies 8 kilometers per second, the astronauts fly 8 kilometers per second. They are perfectly synchronized, so the astronauts do not press on the floor of the station. The floor also falls. The walls fall. Everything falls simultaneously. This is what weightlessness is. It is not the absence of gravity. It is free fall, a state where you and everything around you fall with the same acceleration, and therefore you have nothing to lean on. You can experience this on Earth. Remember an elevator that starts to descend sharply. In the first fractions of a second, you have a strange feeling of lightness in your stomach. Your stomach seems to jump up. This is because the elevator started to fall, and you were momentarily in a state of free fall. If the elevator continued to fall freely, which fortunately does not happen thanks to the brakes, you would start to float inside it. Or remember roller coasters. When the car flies down a steep slope, you feel weightless because you and the car fall together. You do not press on the seat does not press on you, you are in free fall. True, this lasts only a few seconds, but on the ISS, it lasts for years. Interesting fact. On Earth, astronauts are specially trained in weightless conditions using an airplane that flies along a special trajectory. The airplane gains altitude, then sharply transitions into a dive, entering free-fall mode. Inside the airplane, weightlessness occurs for 20 to 30 seconds. Astronauts manage to practice maneuvers and get used to the sensations. Then the airplane gains altitude again, and everything repeats. In one flight, there may be several dozen such cycles. This airplane was nicknamed the Vomit Comet, because many beginners cannot withstand the constant change of G-forces and weightlessness. The stomach rebels, the vestibular apparatus cannot cope. but experienced astronauts get used to it and even enjoy it. Now let us return to the main question. If gravity in orbit is almost the same as on the surface of the Earth, why then talk about microgravity? The term microgravity is misleading. It creates the impression that gravity is very small, almost absent. No, this is not true. The term microgravity is used to describe conditions where free-fall acceleration is compensated and small residual forces arise. For example, because the station rotates or due to the resistance of the thin atmosphere or due to the movements of the astronauts themselves. These forces are indeed very small, hence the prefix micro, but confusing microgravity with low gravity is a mistake. Gravity in orbit is huge. It is what keeps the ISS in orbit. If gravity disappeared, the station would fly in a straight line into outer space like a stone released from a slingshot. Another common myth. If you fly far from Earth, gravity will disappear completely. Also not true. Gravity acts at any distance. Yes, it weakens with distance according to the inverse square law. Double the distance, the force will decrease 4 times, but it will never become zero. Even at the distance of the Moon, almost 400,000 kilometers, Earth's gravity is still perceptible. It is what slightly curves the Moon's orbit. Although the main force holding the Moon is the gravity of the Moon itself, paired with the gravity of the Earth. They dance with each other, rotating around a common center of mass. And if you fly even further to the edge of the solar system, Earth's gravity will be negligible, but it will still be there, and its place will be taken by the gravity of the Sun, which holds all planets, asteroids, and comets in orbits. Let us fly outside the solar system. The Sun's gravity will weaken, but it will be replaced by the gravity of the Milky Way, our galaxy. The center of the galaxy, a massive black hole weighing 4 million solar masses, attracts 300 billion stars to itself, forcing them to rotate in a giant cosmic round dance. Even between galaxies in intergalactic voids, gravity does not disappear, it just becomes very weak. But if you wait long enough, billions of years, even this weak gravity will pull objects toward each other. The universe is permeated with gravity. This is a fundamental force that shapes the structure of the cosmos. Without it, there would be no stars. Gas clouds could not compress enough to trigger thermonuclear reactions. There would be no planets. Fragments would not stick together into large bodies. There would be no galaxies. Stars would fly off in different directions. Gravity is the glue of the universe, and it is everywhere. But let us return to the ISS. Why then do people persistently talk about the absence of gravity? Because intuitively, we associate gravity with weight. We feel our weight when we stand on the floor. The floor presses on our feet, resisting gravity. In weightlessness, there is no such pressure. We float. And the brain concludes, no weight means no gravity. But weight and gravity are different things. Weight is the force with which we press on a support. Gravity is the force with which the Earth attracts our mass. In free fall, gravity does not disappear anywhere. The support simply disappears, and therefore the weight disappears. This is a subtle difference, but it is fundamentally important. Without understanding this, it is impossible to understand how orbits work, why planets rotate around the Sun, why the Moon does not fall to Earth. All these are manifestations of gravity, an eternal, unstoppable fall that turns into motion in orbits thanks to speed and the curvature of space. So next time you see a video from the ISS where astronauts are cheerfully somersaulting in weightlessness, remember, they have not gotten rid of gravity. They are simply falling. They have been falling for 20 years in a row and will continue to fall for a long time, circling the Earth 16 times a day at a speed of 8 kilometers per second at an altitude of 400 kilometers above our heads. Well, and we are moving toward the fourth myth, the one that Hollywood turned into a calling card of space movies. Remember any movie about space, Star Wars, Guardians of the Galaxy, Armageddon. The heroes are flying on a ship, and suddenly an asteroid belt appears in front of them. Thousands, tens of thousands of stone blocks ranging in size from a boulder to a mountain, packed tightly into space. The ship maneuvers between them, now to the right, now to the left. Asteroids rush past several meters from the hull, collide with each other, explode. The pilot masterfully dodges, and the audience is on the edge of their seats, wondering if they will make it through. A stunning sight. Exciting and completely fictional. In reality, the asteroid belt is almost empty space. So empty that if you happen to be there on a spaceship by chance, you would have to try very hard to even see an asteroid with the naked eye, let alone collide with it. The asteroid belt is located between the orbits of Mars and Jupiter. Millions of stone and metal objects rotate around the Sun at a distance of 200 to 500 million kilometers. Sounds impressive. Millions of asteroids, a huge cosmic junkyard. No, here is the catch. These millions of asteroids are scattered over a volume of space so colossal that their density is laughable. Imagine a region the size of billions of cubic kilometers in which several million rocks float, ranging in size from a meter to hundreds of kilometers. The average distance between asteroids is hundreds of thousands, if not millions of kilometers. To understand the scale, let us make a simple comparison. If you took the largest asteroids Ceres, Vesta, Pallas, and laid them out over the entire volume of the belt, then for every cubic kilometer of space, there would be a tiny fraction of a gram of substance. This is less than the density of the air in your room, much less. NASA has sent many probes through the asteroid belt. Pioneer 10 and Pioneer 11 in the 70s, Voyagers in the 80s, Galileo, Cassini, New Horizons. All of them passed the belt without a single collision, even without trying to dodge. They flew in a straight line, and asteroids did not cross their path. Moreover, when scientists plan a mission to an asteroid, for example, to Vesta or Ceres, they specifically calculate the trajectory so that the probe meets a specific object, because a chance meeting is so unlikely that it can be ignored. Of course, asteroids exist. There are many of them. The largest is Ceres, with a diameter of about 1,000 kilometers. It is a dwarf planet, an almost perfect sphere with an icy crust and a stone core. Vesta has a diameter of about 500 kilometers. Pallas is a little smaller. And then there are tens of thousands of objects with a diameter from 100 kilometers to tens of meters and millions of very small fragments. But all this is scattered so rarely that if you stood on the surface of one asteroid, you would not see other asteroids around you. Only a black sky studded with stars. Even through a telescope, a neighboring asteroid could only be seen as a faint moving dot. Where did the myth of a dense asteroid belt come from? Partly, early science fiction novels are to blame. In the 50s and 60s, when the space age was just beginning, science fiction writers imagined the asteroid belt as a dangerous obstacle. This created tension, drama. The heroes had to show skill to pass through the stone labyrinth. Then Hollywood joined in. Visually empty space is boring. The viewer needs action, adrenaline, and directors began to draw dense clusters of asteroids, where every frame is a dodge from another block. It looks spectacular, it works on the screen, but it has nothing in common with reality. Interestingly, even serious popular science programs sometimes sin with this. They show an animation of the asteroid belt where rocks fly in a dense swarm. Not because the producers do not know the truth, but because the truth is visually uninteresting. Drawing several lonely dots on a huge empty background is honest, but not effective. And there is also a psychological moment. When we hear millions of asteroids, the brain automatically imagines something dense and saturated. Millions is a lot. But the scales of space are so huge that even millions of objects are lost in the void. Let us compare with another example. There are 300 billion stars in our galaxy. It sounds like an unimaginable number, but the galaxy is so large that the average distance between stars is several light years. If you were flying from the Sun to the nearest star, Proxima Centauri, you would have to travel 4 light years, or 40 trillion kilometers. And all this space is a void. No stars between them. So 300 billion stars in a galaxy are simultaneously unimaginably many and negligibly few compared to the volume of space. The same with the asteroid belt. Millions of objects, but the space around them is billions of times larger. By the way, another interesting fact. If you collected all the mass of all the asteroids in the belt and molded it into one sphere, you would get an object much smaller than the Moon. The total mass of the asteroid belt is only 4% of the mass of the Moon, and the Moon, in turn, is 80 times lighter than the Earth. Once, astronomers thought that the asteroid belt was the remains of a destroyed planet, the planet Phaeton, which once rotated between Mars and Jupiter, but then exploded or was torn apart by Jupiter's gravity. A beautiful theory, romantic even, but mathematics did not support it. If all the asteroids stuck together into one planet, it would be tiny, with a diameter of about 2,000 kilometers. This is smaller than the Moon, smaller than Mercury. Not a planet, but a dwarf planet at best. The modern theory states, the asteroid belt is material that could never assemble into a planet. When the solar system was forming, there was matter in this region that could have stuck together into a small planet. No, Jupiter was forming nearby, a giant 300 times more massive than the Earth. Its gravity constantly disturbed the orbits of planet embryos in the asteroid belt. They collided at too high speeds, fragmented rather than sticking together. As a result, instead of a planet, millions of fragments were formed. Jupiter is the gravitational bully of the solar system. It not only prevented a planet from forming in the asteroid belt, but also regularly ejects asteroids from their orbits. Some fly to the inner part of the solar system toward Mars, Earth, and Venus. It is because of Jupiter that we sometimes see asteroids flying past the Earth. These are fugitives from the belt whose orbits were distorted by the giant's gravity. And Jupiter also protects us. Its massive gravity attracts many comets and asteroids that could otherwise fall to Earth. In 1994, the comet Shoemaker-Levy 9 fell on Jupiter. It broke into 21 fragments, and each fragment crashed into Jupiter's atmosphere with energy equivalent to millions of atomic bombs. If such a comet fell on Earth, the consequences would be catastrophic. So the asteroid belt is not a danger zone where ships risk crashing into rocks. It is a quiet, almost empty region where lonely fragments slowly circle around the sun, touching no one. And next time you see a movie where heroes maneuver between densely packed asteroids, smile. This is a beautiful fantasy. But in reality, space is much more deserted than we would like to believe. Now we move on to the fifth myth, the one that, thanks to one iconic album, became part of global culture. The dark side of the moon. The very phrase sounds mystical, mysterious. It evokes images of eternal darkness, hidden secrets, and perhaps even alien bases hiding from human eyes. The group Pink Floyd dedicated an entire album to this, which became one of the best-selling in history. Science fiction writers populate the dark side of the moon with secret objects. Conspiracy theorists build theories about what is hiding there. And all this is built on a fundamental misunderstanding of how the moon works. The moon does not have a dark side. It has a far side, the one we never see from Earth. But it is illuminated by the sun exactly like the visible one. Day and night alternate on both sides of the moon exactly the same way. We, Earthlings, are simply stuck in a position from which we can observe only one half of the lunar globe. Why does this happen? It is all about tidal locking. The moon rotates around its axis, but the speed of this rotation is perfectly synchronized with the speed of the moon's revolution around the Earth. One rotation around the axis takes exactly the same amount of time as one revolution in orbit, about 28 days. Therefore, the same side is always turned toward the Earth. Imagine that you are tied with a rope to a pole and walk around it, constantly looking at the pole. To keep looking at it, you will have to turn. In one circle around the pole, you will make one full turn around yourself. Your face will always be directed toward the pole and your back outward. But this does not mean that your back is plunged into eternal darkness. The sun illuminates you from all sides as you rotate. The moon works exactly the same way. It rotates around its axis but synchronously with its revolution around the Earth. Therefore, one side is always turned toward us and the other is always turned away. No, the sun sees both sides. Moreover, when we observe a new moon, when the moon is between the Earth and the sun, it is the far side of the moon that is fully illuminated. The visible side for us at that moment is plunged into darkness. And when we see a full moon, it is the opposite. The visible side is illuminated and the far side is in darkness. So if we are to speak of a dark side, it is constantly changing. Now one half of the moon is in shadow, now the other. Approximately once a month, the sides switch roles. Where did the myth of the dark side come from? Partly, terminology is to blame. Astronomers called the half of the moon invisible from Earth the back side or the far side. But in the English language, there is the expression dark side, which means not only the absence of light, but also something hidden, unknown, sinister. And this word stuck in popular culture. When the album by Pink Floyd was released in 1973, the title The Dark Side of the Moon was used as a metaphor. It was about the dark sides of the human psyche, about madness and social pressure. The musicians did not claim that there is an eternally dark half on the moon, but the name was so catchy that it fixed the myth in the minds of millions of people. And then Hollywood joined in. Movies where secret bases or alien objects are located on the far side of the moon multiplied. The idea was simple. Since we do not see this side, it means anything can be hidden there. Convenient for the plot, intriguing for the viewer. And it is completely unimportant that reality is arranged differently. Interestingly, until 1959, humanity really did not know what the far side of the moon looked like. We saw only one half. The second was a mystery. And then the Soviet apparatus Luna 3 flew around the moon and photographed it from the backside. For the first time in history, people saw what had been hidden from them for millions of years. What turned out to be on the far side? No bases, no cities, no mysterious structures, just a surface covered with craters, very similar to the visible side but with one difference. On the far side, there are almost no dark spots that we call lunar seas. Lunar seas are lowlands filled with solidified lava. Billions of years ago, huge asteroids fell on the moon, breaking through the crust and releasing molten rock. Lava filled the craters, cooled, and turned into a dark basaltic plain. On the visible side, there are many such seas. On the far side, there are only two, the Sea of Moscow and the Sea of Dreams. They were named by Soviet scientists who first saw this side. Why such a difference, scientists are still debating. One version, the crust on the far side is thicker. When asteroids fell, they could not break through it deeply enough to release lava. Another version, the gravitational influence of the Earth played a role. Tidal forces heated the side of the moon closer to the Earth more strongly, making the crust thinner and more pliable. But in any case, the far side is not a dark abyss. It is an ordinary lunar surface, just as gray, covered with craters, illuminated by the sun for half a month and plunged into shadow for the second half. Exactly like the visible side. By the way, there is another interesting point. Due to small oscillations of the moon, which are called libration, we can actually see a little more than half of the lunar surface. The moon slightly wobbles in orbit. Now a little to the left, now a little to the right, now a little higher, now a little lower. These wobbles give us the opportunity to peek over the edges of the visible disk. As a result, we see not exactly 50% of the moon, but about 59%. But 41% still remains hidden from the terrestrial observer. And it was this inaccessibility that gave birth to myths. The human brain does not like uncertainty. We strive to fill in the gaps. And if we do not see something, we invent explanations. Sometimes plausible, sometimes fantastic. In 2019, the Chinese apparatus Chang'e 4 made a landing on the far side of the moon. It was the first spacecraft in history to land there. Why had no one done this before? Not because of some special danger. It is simply technically more difficult. There is no direct radio communication with Earth from the far side of the moon. The moon blocks the signal. To control the apparatus, a relay satellite is needed that will hang over the far side and transmit commands. The Chinese launched such a satellite and then landed the probe. What did it discover? An ordinary lunar surface, gray dust, stones, craters. Nothing unusual, no signs of alien activity, no secret bases. Just the moon, the same as on the visible side. And this is wonderful because reality does not need mystifications to be interesting. The fact itself that the moon is tidally locked to the Earth is amazing, that its rotation speed is perfectly synchronized with its orbit. This is the result of billions of years of gravitational interaction, slow braking by tidal forces. Once, the moon rotated faster. It showed all its sides to the Earth, but the Earth's gravity created tidal bulges on the surface of the moon. Small deformations that slowed the rotation. For millions of years, this braking continued until the rotation speed matched the orbital speed, and the moon froze, turned to the Earth with one and the same side. This is not a unique phenomenon. Most large satellites in the solar system are tidally locked to their planets. Jupiter's satellites are always turned to it with one side, Saturn's satellites too. Even Pluto and its satellite Charon are mutually locked. They always look at each other with the same sides, rotating like a pair of dancers holding hands. Tidal locking is the inevitable result of gravitational interaction between close bodies. The closer the satellite to the planet, the faster the locking occurs. The moon is close enough to the Earth to be locked in several billion years. More distant satellites can rotate freely. Tidal forces at such a distance are too weak. By the way, the process also works in the opposite direction. The moon is not only locked by the Earth, it locks the Earth itself. The moon's tidal forces gradually slow down the Earth's rotation. Billions of years ago, Earth days were shorter, only a few hours. Gradually, the rotation slowed. Now a day lasts 24 hours, and in billions of years, it will become even longer. Ultimately, if given enough time, the Earth will also be tidally locked by the moon. Earth days will become equal to a lunar month, about 28 days, and the Earth will always be turned to the moon with one and the same side. True, this will happen in tens of billions of years, when the sun will already turn into a red giant and possibly swallow both planets. Now, there is also another interesting effect. As the Earth's rotation slows, the moon moves away from us. Every year, the distance to the moon increases by about 4 centimeters. This seems like a little, but over millions of years, a significant distance accumulates. Once, billions of years ago, the moon was much closer to the Earth. Perhaps dozens of times closer. In the sky, it looked huge, not a small disk, but a giant ball covering a significant part of the sky. The tides then were monstrous. Waves hundreds of meters high crashed onto the coast. Now the moon is at a comfortable distance, and it is this distance that creates one of the most amazing cosmic coincidences. The visible size of the moon in the sky almost exactly coincides with the visible size of the sun, therefore total solar eclipses are possible when the moon perfectly covers the solar disk. This is incredible luck. On other planets, this does not happen. Mars's satellites are too small. The satellites of gas giants, although large, are at such distances that they do not create perfect eclipses. Only on Earth, only now, In this era of the solar system's history, can we observe total solar eclipses in all their glory. And this is a temporary phenomenon. In hundreds of millions of years, the moon will move away so much that it will become too small to completely cover the sun. Eclipses will become annular. A bright ring of the sun will be visible around the dark disk of the moon. So the myth of the dark side of the moon is a beautiful legend, but nothing more. The far side exists. It is hidden from us, but it is not dark. It is also illuminated by the sun, just like the half we see every night looking at the sky. And when you next hear a Pink Floyd song or watch a movie about secret bases on the moon, remember, this is a metaphor, an artistic fiction. The real moon is arranged simpler and simultaneously more amazingly. It is a silent witness to Earth's history. A satellite that has been rotating around us for billions of years, influencing the tides, the climate, the very axis of rotation of our planet. And we move on to the last, sixth myth, the one associated with the most spectacular space phenomenon that can be observed from Earth. Imagine night, dark sky, and suddenly a bright trail flashes. A meteor streaks across the sky in a fiery strip, glows brighter and brighter, turns into a blinding fireball. You hear a roar like a clap of thunder, and then an impact. Somewhere in a field, a meteorite fell. You run there and find a smoking stone, white hot, so hot it cannot be touched. That is exactly how they show it in movies. That is how it is described in books. A meteorite fallen from the sky must be hot. After all, it flew through the atmosphere at high speed, heating up from friction to 1,000 degrees Celsius. Only real witnesses of meteorite falls tell a different story. When people find a freshly fallen meteorite, it turns out to be warm, not red hot, not burning, just warm like a heating radiator, and sometimes even cool. How is this possible? Let us take the process of a meteorite falling step by step. A meteoroid, that is what they call a space rock while it is still in space, flies into the Earth's atmosphere at a speed of 11 to 72 kilometers per second. This is a crazy speed. Faster than a bullet, faster than sound, so fast that air molecules do not have time to move aside. And this is where the interesting part begins. The meteoroid crashes into the air as if into a wall. An impact wave forms in front of it, in which the air is compressed to incredible pressures, and when a gas is compressed, it heats up. The temperature in front of the meteoroid jumps to tens of thousands of degrees. The air turns into plasma, an ionized gas that glows. It is this glow that we see as a meteor. The fiery trail in the sky is not a burning stone. It is glowing air. The meteoroid flies through the plasma it creates itself. The surface of the meteoroid really heats up, but not from the inside, but from the outside. A thin layer of rock melts, evaporates, and is blown away by the airflow. This process is called ablation. The meteoroid literally melts in flight, losing mass. Small meteoroids burn up completely without even reaching the surface. Large ones manage to slow down and reach it. Now here is what is important. Inside, the meteoroid remains cold because heat transfer is not an instantaneous process. For heat from the red-hot surface to penetrate into the depth of the stone, time is needed, and flight through the atmosphere takes only a few seconds. The surface melts and evaporates, but the interior does not have time to warm up. Moreover, when the meteoroid has slowed down enough, usually this happens at an altitude of 10 to 20 kilometers, ablation stops. The speed has dropped so much that the air no longer compresses in front of the stone and the temperature falls. The meteoroid enters free fall mode, like an ordinary object dropped from a great height. And here an amazing thing happens. The meteoroid flies through the cold air of the upper layers of the atmosphere. The temperature there is minus 50 to 60 degrees. The thin, melted crust on the surface of the stone cools in seconds, and inside the stone is still cold. After all, it came from space where the temperature is close to absolute zero. By the time it hits the ground, The meteorite has cooled almost completely. The crust hardens, turning into a black glassy shell called a fusion crust. It serves as an excellent thermal insulator. Under it is a cold stone. Witnesses of falls confirm this. In 1947, the Sikhote Alin meteorite shower fell in the Far East. Thousands of fragments rained down on the Earth. People who ran to the fall site in the first minutes discovered that the fragments were warm, but not hot. They could be picked up with bare hands. In 2013, a meteoroid about 20 meters in diameter exploded over Chelyabinsk. The shock wave blew out windows in thousands of homes. Fragments fell onto the ground and onto the ice of a lake. Fragments found shortly after the fall were cold. Some were even covered with frost. Moisture from the air condensed on their cold surface. So where did the myth of red-hot meteorites come from? Partly because of logic. It seems obvious. If a stone flies at high speed, sparkles in the sky with a fiery trail, then it must be hot. Intuition suggests exactly this. No, intuition is deceptive because intuition is based on everyday experience. We are used to heated objects cooling down for a long time. A frying pan after frying remains hot for dozens of minutes. Red-hot metal cools slowly, but a meteorite is a different matter. Its surface heats up for fractions of a second and then immediately falls into the icy air of the stratosphere. Another reason for the myth is confusion between a meteor and a meteorite. A meteor is a light phenomenon, a trail in the sky. A meteorite is a stone that has fallen to Earth. We see a bright, fiery meteor and think, there it is, a red-hot stone. But fire is not a stone. Fire is plasma around the stone, and the stone itself inside is cold. By the way, astronauts returning to Earth face the same problem. The capsule enters the atmosphere at a speed of 8 kilometers per second. An impact wave forms in front of it. The temperature jumps to several thousand degrees. The capsule's hull heats up to a red glow and begins to melt, but inside the capsule, the astronauts sit in relative coolness. Thermal protection and ablative coating do not let heat penetrate inside. Ablative protection works on the same principle as a meteorite. A special material melts and evaporates, carrying away heat. The outer layer is destroyed, but the interior remains protected. Exactly the same happens with a meteoroid, only in its case, the rock itself undergoes ablation. There is another curious point. Sometimes meteorites fall into snow or ice and are found later in small pits surrounded by melted snow. People see this and think, aha, the meteorite was hot, it melted the snow. But most often the snow melts not from the heat of the meteorite, but from the energy of the impact. A meteorite crashes into the ground at a speed of hundreds of meters per second. This is still very fast. The kinetic energy of the impact turns into heat. The ground heats up, the snow melts, but the meteorite itself remains cold. True, there are exceptions. If a meteorite is very large, if it did not have time to slow down enough in the atmosphere and crashed into the ground at huge speed, then yes, the impact will be so powerful that a colossal amount of energy will be released. The meteorite will evaporate completely or partially, forming a crater. That is exactly how the Arizona crater was formed. More than a kilometer in diameter, the trail of an iron meteoroid impact weighing hundreds of thousands of tons. But such events are rare. Ordinary meteorites, dozens of which fall per year across the planet, weigh from several grams to several kilograms. They manage to slow down, cool, and fall relatively quietly. And here is what else is interesting. Meteorites can actually be used to study the cold of space. Inside large meteorites, minerals are preserved that formed billions of years ago in conditions of deep cosmic cold. By analyzing these minerals, scientists can find out at what temperature they formed, how long they were in space, and what radiation they were exposed to. Meteorites are messengers from the past. Some of them are 4,500,000,000 years old, the age of the solar system itself. They remember the times when the Earth was just forming. And they carried this memory through billions of years, through the cold of space, through the fire of atmospheric entry, and fell into our hands to tell their story. Carbonaceous chondrites are particularly valuable, a type of stone meteorites containing organic compounds. Amino acids, the building blocks of proteins, are found in them, sugars are found, complex organic molecules are found. This does not mean that meteorites carry life, but it means that the chemical precursors of life could have been brought to the young Earth from space. Imagine, billions of years ago, our planet was subjected to intense meteorite bombardment. Every day, hundreds, thousands of meteorites fell, and each carried organic molecules, water, and minerals. Perhaps it was this cosmic rain that seeded the Earth with the ingredients from which life later arose. There is even a panspermia hypothesis, the idea that the simplest forms of life, possibly even bacteria, could travel between planets on meteorites. An asteroid impact on Mars ejects fragments of Martian rock into space. Some of them, after millions of years of wandering the solar system, fall to Earth. If frozen microorganisms are preserved in the rock, they could theoretically come back to life on a new planet. There is no evidence of panspermia, but the very fact that such a thing is possible in principle captures the imagination. Maybe we are all Martians or Venusians. Or on the contrary, terrestrial life spread through the solar system on meteorites ejected from Earth by ancient impacts. There is another curious point. Sometimes meteorites fall into snow or ice and are found later in small pits surrounded by melted snow. People see this and think, aha, the meteorite was hot, it melted the snow. But most often the snow melts not from the heat of the meteorite, but from the energy of the impact. A meteorite crashes into the ground at a speed of hundreds of meters per second. This is still very fast. The kinetic energy of the impact turns into heat. The ground heats up, the snow melts, but the meteorite itself remains cold. True, there are exceptions. If a meteorite is very large, if it did not have time to slow down enough in the atmosphere and crashed into the ground at huge speed, then yes, the impact will be so powerful that a colossal amount of energy will be released. The meteorite will evaporate completely or partially, forming a crater. That is exactly how the Arizona crater was formed, more than a kilometer in diameter, the trail of an iron meteoroid impact weighing hundreds of thousands of tons. But such events are rare. Ordinary meteorites, dozens of which fall per year across the planet, weigh from several grams to several kilograms. They manage to slow down, cool, and fall relatively quietly. And here is what else is interesting. Meteorites can actually be used to study the cold of space. Inside large meteorites, minerals are preserved that formed billions of years ago in conditions of deep cosmic cold. By analyzing these minerals, scientists can find out at what temperature they formed, how long they were in space, and what radiation they were exposed to. Meteorites are messengers from the past. Some of them are 4,500,000,000 years old, the age of the solar system itself. They remember the times when the Earth was just forming, and they carried this memory through billions of years, through the cold of space, through the fire of atmospheric entry, and fell into our hands to tell their story. So next time you see a falling star, and in reality it is a burning meteoroid, remember? The fiery trail in the sky does not mean the stone is red hot. It only means that the air around it is so strongly compressed and heated that it began to glow, and the stone itself, if it reaches the Earth, will turn out to be no hotter than a cup of freshly brewed tea. And this concludes our list of 6 main space myths. But before putting a period, let us stop and think. Why did these myths arise at all, and what unites them? 6 myths, 6 misconceptions, each of which has lived in the mass consciousness for decades, if not centuries. The Big Bang that did not explode, the sun that is not yellow, weightlessness that is not about the absence of gravity, the asteroid belt that is not dense, the dark side of the moon that is not dark. Meteorites that are not hot. What is common between all these myths? They are convenient, they are simple, they are intuitively understandable. An explosion is easier to imagine than the expansion of space itself. A yellow sun is more familiar than a white one. The absence of gravity explains weightlessness more simply than the concept of free fall. A dense asteroid belt is more spectacular than empty space. The dark side of the moon is more mysterious than the far side. A red-hot meteorite is more logical than a cold one. The human brain likes to simplify. This is an evolutionary necessity. Our ancestors could not afford to spend time on deep analysis of every phenomenon. They needed to make quick decisions. You see movement in the bushes. Run, not figuring out if it is a tiger or the wind. It is better to be wrong and stay alive than to be right and dead. This same logic works now. We create simplified models of the world that help us navigate, and most of the time these models work. No, sometimes, especially when it comes to phenomena distant from everyday experience, simplification becomes distortion. Space is far from our experience. We do not live in weightlessness. We do not see the asteroid belt with our own eyes. We cannot fly to the far side of the moon. Therefore, our brain fills the gaps with what seems logical, and logic based on everyday experience often errs. And here is what is surprising. Even when the truth is explained to us, we resist because the myth has already taken root. It has become part of our picture of the world. To give it up means admitting we were wrong, and that is uncomfortable. Psychologists call this cognitive dissonance. When new information contradicts our beliefs, the brain experiences stress, and it is easier to dismiss the new information than to reconsider beliefs. But there is another reason for the persistence of myths. Culture. Myths are passed from generation to generation through books, movies, songs, and textbooks. A child draws a yellow sun because that is how their parents drew it. A director films a dense asteroid belt because that is what they showed in the movies they watched as a child. A writer describes the dark side of the moon because it is an established literary image. Myths are memes in the original scientific sense of the word, units of cultural information that are copied from person to person. And some memes turn out to be very persistent, even if they are not correct, because they hook you, because they are beautiful, because they provide simple answers to complex questions. Now, does this mean we are doomed to live in a world of misconceptions? No, because we have science. Science is a tool that allows us to check hypotheses, sift through false beliefs, and get closer to the truth. Science is not perfect. Scientists also make mistakes, and theories are revised. What seemed like truth yesterday may turn out to be a misconception tomorrow. No, this is the strength of science, in the readiness to admit mistakes and move on. 100 years ago, we did not know the universe was expanding. We thought the Milky Way galaxy was the entire universe. We did not understand how stars work. Now we know. We have looked into the past for billions of years, seen the birth of the first galaxies, understood how planets form, and with each new discovery, our picture of the world becomes more precise, but also more complex, because simple answers are rarely correct. The universe is not obliged to be understandable. It does not adapt to our intuition. It exists according to its own laws, which we are slowly, step by step, deciphering. And here is the paradox. The real universe is much more amazing than any myths. The expansion of space itself. A white star that appears yellow due to the atmosphere. A fall that never ends. A void filled with rare fragments. The moon synchronized with the Earth by billions of years of gravitational interaction. Meteorites that bring us the cold of space. Each of these facts is a window into the structure of the world. Each piece of the puzzle that we put together, trying to understand how reality works. And maybe the most important lesson we can learn from debunking myths is humility. Humility before the complexity of the world. Readiness to admit that our intuition is not always right, that simple explanations can be wrong, that truth requires effort. No, these efforts are worth it, because understanding the real world gives us power. The power to predict, the power to create, the power to survive. Our ancestors looked at the stars and saw gods. We look at the stars and see thermonuclear reactors, black holes, neutron stars, exoplanets. We know what they consist of, how they are born and die. We can launch a probe to another planet and land it at a pre-selected point with an accuracy of meters. This is an incredible achievement, and it became possible because we abandoned myths and accepted science. No, here is the paradox. Myths do not disappear completely. They evolve, adapt, and mimic scientific facts. And even knowing the truth, we continue to cling to familiar images. Yellow suns on children's drawings, dense asteroid belts in movies, the dark side of the moon in songs and books. Maybe it is not so bad. Maybe myths perform an important function. They make space understandable, close, and human. They allow us to emotionally connect with phenomena that would otherwise remain cold abstractions. It is only important to remember where the metaphor ends and reality begins. It is important not to confuse a beautiful story with a scientific fact. It is important to maintain curiosity and readiness to reconsider one's beliefs when new data appears. Because in the end, science is not just a collection of facts. It is a way of thinking, a way of looking at the world without bias, asking questions, checking hypotheses, and admitting mistakes. This is intellectual humility combined with unquenchable curiosity. And when we apply this approach to space, we discover that reality surpasses any myths. An expanding universe, curved space-time, black holes where time stops, neutron stars where matter is compressed to unthinkable density, exoplanets rotating around distant suns where life may exist. All this is not fiction. This is reality discovered thanks to science, a reality that continues to surprise us again and again. So yes, the Big Bang did not explode. The sun is not yellow. Weightlessness is not about the absence of gravity. The asteroid belt is not dense. The dark side of the moon is not dark. Meteorites are not hot. And this is wonderful because reality does not need myths to be amazing. It is already full of wonders. One only needs to open their eyes and look. We have gone through 6 cosmic myths. Each of them seemed obvious. Each was part of popular culture. And each turned out to be false. No, the most important thing is not that these myths are incorrect. What matters is that their debunking opens our eyes to the real structure of the cosmos. And this structure turns out to be much more exciting than any fiction. The universe began not with an explosion, but with the expansion of the very fabric of space-time, a process that continues right now while you are watching this video. The sun shines with white light, which the atmosphere colors in yellow and red, creating a daily spectacle for our eyes. Astronauts float not because they got rid of gravity, but because they are infinitely falling, circling the Earth with incredible speed. The asteroid belt is an almost absolute void where rare stone fragments keep the memory of the birth of the solar system. The moon is synchronized with the Earth, showing us one and the same face for billions of years. No, both its sides are equally illuminated by the sun. And meteorites bring us not the heat of space, but its cold, conveying a message from the times when our planet was only just being born. Each debunked myth is another step toward understanding reality, and each step shows how amazing the world we live in is. If this video changed your view of space, support the channel with a like and a subscription. Ahead are many more mysteries that we will solve together. For now, look at the stars. Only now you know a little more about them than before.